Hey guys, so we started the class same way as we did yesterday. Practice filling out the unit circle, or you can try to play the little game online. So take a few minutes, try to do that. That's important for you guys to remember. Okay, so we talked about domain of trigonometric functions, domain and range. Remember with the sine function, it's the sine of an angle here. Okay, so the input or the domain is going to be t, or the angle. So in trying to find the domain, we ask ourselves the question, is there an angle that I cannot use to put into the sine function? And the answer is no. There's all sorts of angles. I can go negative as far as I want in the negative angles. I can go as far as I want in the positive angles. So we would say that the domain for a sine function is all real numbers, or negative infinity to positive infinity. Again, we are in an xy coordinate system, okay? And we do have this unit circle. So I can go around and around and around as many times as I want to for those angles. And sine is going to be all of the y values, okay? Now, the range would be the minimum and the maximum y values. So the minimum it goes is right here at -1, and the maximum it goes is right here at +1. And again, these are my y values. Also, we have cosine. So that's the cosine of an angle. Again, the angle can be any angle, negative or positive. This represents my x's. Okay, so the domain is going to be my angles to which there is no limit. So it's all real numbers, or negative infinity to positive infinity. So that means I can have any angle and find the cosine of that angle. Now, the range, even though we're talking about the maximum x and the minimum x, that is the range they are referring to. So the minimum of x is -1, and that's when it's at pi. And the maximum x is going to be at +1, and that's when we have an angle of 0, or we have an angle of 360 degrees, or 2 pi. Okay? Adding 2 pi to each value of t completes a second revolution. So it's actually the same here. And this 2 pi we call a period. Okay? 2 pi we call a period. So one revolution is also known as a period. I could get back to that same spot. So let's just say here's my circle, and at pi/4, well, I can add another 2 pi and I end up at the same location. So I just have to add what the pi/4, so that'd be 8 pi/4. So I've got pi/4. That's going to be the same as 9 pi/4. If I subtract it, it would be a -7 pi/4, etc. So all of these coterminal angles here represent a period, a completed period in these functions. Okay, so speaking of a period, we just want to specify that for sine and cosine and tangent, they display periodic behavior. So they are periodic because they can have multiple revolutions. So this is just showing that if I take f of t, so maybe that's a function of pi/4, we'll use the same example. That's going to be the same as a function of pi/4 plus 2 pi. Which is going to be a function of 9 pi/4. And they will have the same sine values, the same cosine values, and they're just representing periodicity or periodic behavior. Okay, then that brings us to odd and even functions. There's a little section in your book, but basically, since cosine is my x values right here, all these x values will be the same, and all these x values will be the same. So whether it's a positive pi/4 or a negative pi/4, those values for cosine will always be the same. Okay, so we say that they are even functions. So the cosine of a negative pi over 4 is going to be equal to the cosine of a positive pi over 4. And this only works for cosine, and then of course secant is the reciprocal of cosine. So that's going to be the square root of 2 over 2, and this will be the square root of 2 over 2. If I wanted to change that, let's say we used cosine of pi over 3, we'll say negative, and that's going to equal the cosine of a positive pi over 3. All right, so cosine of negative pi over 3, that's right here, is positive 1/2 because it's on the right side of the y-axis. And the cosine of positive pi over 3 is also 1/2 because it's still on the right side of the y-axis. So again, cosine and secant are even functions. And then of course we have odd functions here. So the reason we have odd function is because they all involve y. All right, so remember this is going to be y over 1, this is going to be 1 over y, this is going to be y over x, and this is going to be x over y. And so anything that has a y is going to be odd because with y, you have to cross over the x-axis, and so things will change there. Meaning, the sine of negative pi over 6 is not equal to the sine of positive pi over 6, but we make that negative, and then the sine of positive pi over 6. So I could take the sine of pi over 6 and just negate it for a negative angle. So I can take the sine of pi over 6, which is 1/2, and I can negate it to get this value. All right, so make sure you've got those written down. You're going to want like a whole page of all these formulas and these boxes just to hang on to in your notes. So your practice here, we're going to change that to 71. There's a few word problems, but it's really just the same as approximating. But before you do that, let's talk about approximating these trig expressions. When you put these in your calculator, just make sure that you're in the correct mode. Mode is very important here. If you don't check your mode, you're going to get the wrong answers. So look for those modes. Before you input anything into your calculator, check what it is that you're putting into your calculator, and then fix the mode. All right, so when you do that, you're just going to take mode. I'm going to change it here to radians. Okay, and then I'm going to press the sine of 1.5 and hit enter. And so that is the sine of 1.5. It's approximately 0.9775. Okay, tangent of 36 degrees. So I need to change my mode, go back to degrees, hit enter, quitting, and then I press the tangent of 36. And so I get approximately 0.7265. Okay. Secant, so secant is a reciprocal. So basically, secant is 1 over cosine. So if I put in my calculator 1 divided by the cosine of negative 2.75, then I will get my secant. Okay, so basically it's a fraction. 1 over the cosine of negative 2.75. Another way to write that is if I just put it in my calculator, find the cosine of negative 2.75, and then raise it to the -1 power. Okay, so I'm going to show you both ways. First, I got to go to radians. So I'm going to check mode, go to radians, and then I'm going to do 1 divided by parentheses, cosine of negative 2.75, close parentheses, and hit enter. Okay, and I get approximately negative 1.0819. Now, this is okay. So I know we talked about how cosine, you can't have a -1 or bigger than a 1 or a -1. But this is a secant. This is a reciprocal. So it's okay. These will actually be smaller than -1 and bigger than 1 when they are reciprocals. Okay, so cosecant is very similar, only here we're in degrees. And I'm going to show you the other way. So this is really 1 over sine. Okay, so I'm going to take the sine reciprocal of 105 degrees and close parentheses, and then I'm going to raise it to the -1 power. That is the same. So I'm going to press mode. I'm going to go back to degrees. And then I'm going to press parentheses sine of 105 degrees, close parentheses, raised to the -1 power. You see that right there? -1 power, and hit enter. And so this is approximately 1.035. I usually take 4 decimal places. Okay, so again, here's your suggested practice. Also, for homework, after yesterday's unit circle, I have this table that I uploaded to Canvas. You want to try to go through and fill out these values. Remember, sine is your y's and cosine is your x's. And it might help to put your points over here in the margin. So that's going to be the square root of 3 over 2 and 1/2. And then you're going to evaluate all of these so that your table is filled out. The key is also posted in case you get confused. So please have that filled out along with your unit circle. Okay? Monday, be prepared for a skill check. Somehow. We're all going to have a skill check. So, you guys have a great day.